In this video here, we're going to take a look at variable acceleration in one dimension. Now you should be aware then that the equations of motion for constant acceleration allow us to write velocity and displacement as functions of time. And when a body experiences variable acceleration, we can model the acceleration as a function of time, and by using calculus we can describe the relationship between displacement, velocity and acceleration. So just recall then that the velocity v is the rate of change of displacement with respect to time t. So in that case then, v is equal to ds by dt, and s is equal to the integral of v dt. And in a similar fashion here then, the acceleration a is the rate of change of velocity, again with respect to time t. So in that case then, a is equal to dv by dt, which is the same then as the second derivative of s here, the displacement, again with respect to time t. And v is also equal to the integral of a with respect to time t, so dt there. So to finish with here then, you do need to be confident with all differentiation and integration techniques from A-level maths. So just make sure then that those differentiation and integration skills are up to scratch. But other than that, we don't need too much more here in terms of an introduction to variable acceleration in one dimension. Let's just work through one practice question together. So let's just get started then with this practice question here. So for this question, we have a particle of mass 5 kilograms that is moving on the positive x-axis. At time t seconds, the displacement s of the particle from the origin is given by the following here. So for the first part of the question, part A, all we want to do is find the velocity of the particle when t equals 2. So for part A then, don't forget here that we're given the displacement to begin with. So if we want the velocity, don't forget then that the velocity is just the derivative of the displacement s with respect to time t. So v is equal to ds by dt here. So ds by dt. Okay. So nice and straightforward in this case here, right? Just differentiate s with respect to t, just basic differentiation, just go term by term. So in that case then, what we get here is 5 over 2t, reduce the power by 1 now, so 5 over 2 minus 2 over 2 gives us a power of 3 over 2 there, like so. And now for the second term here then, so e to the minus 3t over 2, once we differentiate that with respect to t here, what we get then is the following. So we get minus 3e to the minus 3t all over 2, okay? And this here then is for the velocity, so my units then are meters per second. So ms to the minus 1 there, like so. Now we're not done here because what we want to know is the velocity of the particle when t equals 2. So basically, all we need to do here now is just substitute t equals 2 into this result here. So when t equals 2 then, what do we get here? So in that case then, just use your calculator here, right? Just substitute t equals 2 into this result here. And if you do this correctly then, the velocity v is equal to 11.2 meters per second. So don't forget units here, right? Like so. And there we have it. So that gives us the solution to part A to 3 significant figures. So now for the second part of this question, then part B, well, we're given that the particle is acted upon by a single force of variable magnitude F newtons, which acts in the direction of the positive x-axis. So for part B then, we want to find the value of F when t equals 3. So let's just do this underneath here. So for part B then, well, if we're looking at forces here, right, clearly we're going to use F equals ma. Now, we already know the mass of the particle here, right? That's what we was given at the beginning of the question. So the particle has a mass of 5 kilograms. What we can now find is the acceleration, right? Again, just by using calculus here. So don't forget then, if we have the velocity, in that case then, the acceleration here, a, is equal to dv by dt. So what we need to do here now is differentiate this result here with respect to t. So 5 over 2 times 3 over 2, that gives us 15 over 4 there. So we get 15 over 4 t. And again, just reduce the power by 1 here. So we get 1 over 2 there as our power. And now differentiating this term here then. So hopefully nice and straightforward, right? We get plus 9e to the minus 3t all over 2. Okay. Now, we want to find the value of f when t equals 3. So to begin with here, let's just substitute t equals 3 into this result here. So when t equals 3, again, just use your calculator to evaluate this here. And if you do this correctly, then what you should find here for the acceleration, again, to 3 significant figures here, is we get a is equal to 6.50. Okay. My units here being meters per second, like so. And then finally, let's just use f equals ma here. Okay. So now using f equals ma. So we know the mass of the particle, we also know the acceleration. So in that case then, f here is equal to the mass, which is 5 in this case. So 5 times by the acceleration, which is 6.50, like so. And in that case then, just put this into your calculator out, or just evaluate by hand, whichever you prefer to do. Obviously much easier to just use a calculator, but either way, what you should get here then is 32.5 newtons there. Okay. And there we have it then. So that gives us the value of f when t equals 3. And there we have it. So that gives us the solution to part B, and it gives us the solution to the one practice question for this video. And that brings us to the end then of this video here on variable acceleration in one dimension.